10.2, we're taking a look at 10.2 and 10.3 at displaying data. In fact, if you look at the titles of these sections, they're both titled displaying data. This one's displaying data part 1, 10.3 is displaying data part 2. It's like they took the entire section of material and then they cut it in pieces. I don't want to say in half because 10.2 is a little bit meatier. There's more of it. The material in 10.3 is a little bit more complicated, but it's not as much. So we're going to start with pictographs. So as we're taking a look at the graphs in this section and the next, this spans graphs across the curriculum from like kindergarten all the way, through kind of the early high school. So you're going to see some things that you're going to be like, that's not going to apply to me. And it may be different things for different ones of you, right? So the earlier things that we're looking at are definitely things that occur at lower levels. And pictograph is a very good example. I remember my daughter doing pictographs in pre-K. So pictograph you've probably seen and heard before. So a pictograph uses pictures to represent tallies within categories. Okay, so the one that I remember my daughter doing is that they counted jelly beans, and they did a pictograph with jelly beans, like they actually drew the jelly beans on there and so forth. That's one I remember specifically, most recently anyway, from a pre-K class. We're not going to do one that's got jelly beans. Ours is going to be a little bit more, it's a little bit, we'll say it's not pre-K appropriate. Okay. An Automobile Club of America considers holiday weekends to start Friday at 6 p.m. and to last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, right, this is why we're not doing this with the pre-K kids, okay? 80 people died from 6 p.m. Saturday to 6 p.m. Sunday, and then 100 people died from 6 p.m. Sunday to 6 p.m. Monday. Draw a pictograph of the data. All right, are we happy? No, it's very sad. Okay, so let's take a look at how this works. One of the reasons that I've chosen this particular problem is not really about the morbidity of it necessarily, obviously, but because the numbers are a little bit bigger, and I want you to see how you can use a pictograph when the numbers are a little bit bigger. It's pretty obvious when you're working with the itty bitties. What you would do is that, one jelly bean would represent one jelly bean. We draw the jelly bean to represent the jelly bean. That's fine. But you can do this with bigger values, and there's a way to accommodate for the fact that there's 100 people without drawing 100 people. We're not going to draw 100 people, okay? Y'all good with that? Nice. All right, so the pictograph starts out looking like this. You're just going to have lines representing the different categories of data. So I've got 3 different time frames that it references. I'm going to draw 4 lines to separate them. The first one is going to represent the Friday to 6 p.m. until, where was it? Friday at 6 p.m. until Saturday at 6 p.m. So this is Friday to Saturday. The times don't overlap, so I'm just going to specify Friday to Saturday, and then we have our Saturday to Sunday, and then we have our Sunday to Monday. Okay, is that okay so far? And if you designate them slightly differently, it's not a big deal. Now, like we said, we don't really want to draw 150 or 100 or even 80 different images of anything, even tally marks. That would be super annoying, wouldn't it? So we're not going to do that. We're going to take a look at the values and figure out what they would all nicely kind of divide by. So we have 80, 150, and 100. And we have a couple of different pretty good options. One option is we could divide them all by 10, which isn't bad. If I divide 150 by 10, I have to create 15 images of something. It's not terrible. You could also divide them by 20. Now, I know 150 doesn't divide by 20 evenly. I understand that. But I'd like to do that one because it lends itself more nicely into one of the examples that you're going to see in your textbook. So we're going to let our image be the value 20. Let me shift this up. In order to do that, we have to create an image that divides in half distinguishably. For example, squares don't divide very well. Well, they can. You can do a square and then divide it in half like that. But if you do a square and you divide it in half like that, it still looks kind of like square, and it can be kind of confusing. So I'm going to choose images that I feel like I can divide nicely and have distinct images. So the image I'm going to choose on this one is I'm going to choose a heart because it divides in half very nicely to be very clearly half of a heart. Okay? So there's other images you can do. Circles are not bad. You can divide a circle pretty nicely in half, and it looks like half a circle. Especially if you were trying to divide a circle into like a quarter. It's easy enough to divide a circle into a quarter to look like, whoa, I didn't do that right at all. To look like a quarter of a circle. You can see how a circle works pretty nicely on that. I'm going to use a heart. So my heart is going to represent that this is 20 people. And this is called a key, and I need a key if I'm going to use an image to represent something, which is exactly what I'm doing on this problem. That key is necessary. The other thing that's necessary is you're going to need a title for every graph. You can do it before, you can do it after, you can do it above, to the side, below. It doesn't matter where or when you do it, it just needs to be on there. I've got space below, so I'm going to do mine below. And this graph needs to have, or this title for this graph needs to represent what's going on. So something like deaths on a holiday weekend. Now, you could incorporate the heart equals 20 people inside of the title if you want to, or you can do it separately. It doesn't matter, but it just needs to be on there somewhere. Okay? Now, as you're drawing your images, whatever images you've chosen, you need to make sure that the images you draw are approximately the same size. Okay? Otherwise, there's sort of an illusionary effect that can sometimes make something look like it has more or less than it does. And you need to draw them so that they line up. Okay? So in other words, this is not what we want. I'm going to draw a couple things that we don't want. I don't want a big heart and then a little heart. I don't want a heart that's really close and then a heart that's really far away, right? Like this is not helpful. In particular, I also don't want, like, if I even had these all the same, I don't want one of them sandwiched in there tighter, because now all of a sudden these four look like they're just as long, kind of, as the three. Are you with me on that? Okay. And when children do it, a lot of times too, it'll almost be gridded. And so that's what I exactly remember from my daughter's jelly bean one, is that they had these lines that sort of separated them to keep them lined up. So if you wanted to do lines to keep them lined up, you could do that too. I won't on mine. So we've got our heart, and we're going to work with, oops, I didn't mean to do that. Let's try one more time. We're going to work with the number for each of the categories. So the first category said that they had, 150 people died on such a weekend from 6 p.m. Friday. Did I do it right? By 6 p.m. Saturday. There we go. So the Friday to Saturday is 150 people. So if 150 people and a heart represents 20 of them, how many hearts do I need? How many hearts would I need to represent 150 people? Okay, well, right there, that's 40. 7.5. You'd need 7.5. Whoa. Okay. Let's try again. Okay, so there's 3 of them. That would be 60. 4, 5, 6, and 7. So there's my 140 people. And then, as Faith said, I still am missing 10, so I would need another half of one, like 7.5 hearts. And to do half my heart, I'm going to draw it like this. There's half my heart. Okay, are we good with that? Okay, how many people died on the Saturday to Sunday time slot? What's it say? 80 or 100? Which one's which? Because I've got 2 answers. Is that one 80? 80. Okay, so how many hearts will represent our 80? 4. So here's 2, 3, and 4. And notice I'm lining them up right underneath the ones above them. And then how many from Sunday to Monday? That one's 100. And how many hearts will that be? 5. So we'll line those up underneath. And this would be a graph, a pictograph of this data. So as you can tell, there's some flexibility in a lot of places, right? Like we could have chosen the heart to be 10 people. We could have chosen an image that wasn't a heart where we didn't need to divide it. I could have certainly used rectangles or squares if I wasn't dividing something in half really nicely, right? That would be okay. But images that you have that are more, you could use people. I could draw a person in here and let the person represent 10 people. Probably letting the person represent 20 people would make it difficult to draw half of a person, right? I could probably do it, but it would look a little bit weird, right? So you kind of keep in mind what you're working with and how that divvies up well or not. Any questions on our pictograph? Okay, so very closely aligned with a pictograph is a dot or a line plot. We're going to call it a dot plot. There are some resources that call this a line plot, but I don't want you to confuse this with a line graph, which we will have later. So we're going to call it a dot plot, okay? So this is a quick way to display data with fewer than 50 values. Okay, something fewer than 50 going on. Okay, So our example that we're going to use is this one. So this is the mass in kilograms of each child, and I really feel like this shouldn't say kilograms, so we're just going to change this to make it actually make more sense. It really should say pounds, because Mrs. Good was a kindergarten teacher, and 46 pounds is reasonable for a kindergartner, but 46 kilograms means the kindergartner is about 100 pounds. And I don't really think we want 100-pound kindergartners running around very much, so we're going to change it into pounds to make it make sense. Sound good to y'all? Lovely. Okay, so these are the pounds for each of Mrs. Good's class. And so she's got, one kid weighs 40, one's 42, one's 49, one's 41, and so on. Okay, makes sense what the data is that you're looking at. Yep, okay. Alrighty, so we're going to make a dot plot for this. So you're going to draw a horizontal line all the way across, and we're going to make it like a number line. Okay, so what we need to do is we need to look for the lowest value and the highest value within the data set that we have. So somebody tell me the lowest value you found. I think 39 is it, yep. And the highest value? 49. Okay, pretty good so far. So we're going to draw hash marks across the bottom to represent every one of those values. Depending on how spread out those values are, you could draw it so that it's like representing every other value or something like that. But these aren't very far spread apart. I mean, from 39 to 49, I'm only going to have to make like 12 hash marks. So we're going to draw all of them on this one. And they're actually all present in the data set, which is a little unusual as well. So I want to make sure that they're there. So here's 39, 40, 41, 42. I'm going to pause. These should be evenly distributed, at least approximately so. There shouldn't be any glaring weirdness to it, okay? And we're going to label every single one of them just because there's not very many. Certainly, if there were more of them, you could draw the hash marks and label every other one or something like that too, and that would be acceptable. So 43, 44, 45, 46, 47, 48, and 49. Okay, so it's not perfect, but it's not bad. My 49 at the end looks a little bit spread out. I think I'm going to shift that over a little bit. It might be a little bit better. It's not bad, okay? I think it's tolerably okay. It's okay. And then what we're going to do is you can actually use dots if you want to. If you use dots, I would make sure they're thick. So when we draw like the number 40, I would make sure that you draw a very thick dot at 40, like that. Another way to do it, and the way that I'm going to show it actually, is that I'm going to draw it as a little X, like this. Okay, so you can see them done in either way. And we're just going to go through each one of these and make sure that they show up on show up above the value that they are. So we've got 42 right here, and then we have a 49. Okay, so no matter what you choose, whether it's a dot or whether it's an X, they need to be about the same size, kind of like with my hearts on the last one, drawing them about the same size as the other ones I've drawn, and at about the same height as the other ones I've drawn, okay? We've got a 41, a 43, and then when we duplicate something 42, we just stack it on top, okay? Whether it's dots or it's X's. 48 and 39, 46 and 41, 42 and 40, 49 and 45, 39 and 43, 47 and 44, and 49 and 42. The tighter you cram things in, the harder your graph is going to be able to read. So when you have the ability to stretch things out, because you've got the data set like we do right here, make sure you kind of stretch things out and make it very readable or very legible. Okay, so this one does not need a key because the X is representing one specific child each time, so we don't have to draw in or write in a key for this one, but we do have to write a title. We're going to have a title on every single graph. So what might we title this graph? What are these values representing? Yeah, and it called it mass, so I'll use mass as well. So mass, and then I changed it to be in pounds, so we're going to specify that this is in pounds of, what did you want me to say, Aubrey? Yes, of Mrs. Good's students. Now, Mrs. Good was my daughter's, she was actually the pre-K teacher, which I think is a fantastic name for a teacher, Mrs. Good. It's lovely, isn't it? It's so nice and like friendly. It's good. All right. Make sense? Okay. All right, our next one. So those two right there are looking at younger grades that we've done before. We're moving a little bit older with the next one. This one certainly could be used somewhere in the middle to upper grades of elementary school and beyond. Like you can definitely use it for you in this class, and it would make sense as well. So this is called a stem and leaf plot. So in a stem and leaf plot, it's akin. That's not akin like Dr. Aiken. That's akin. Akin to the dot plot. Means it's kind of like it. It's drawn vertically, and the numbers on the left are called stems, and the numbers on the right are called leaves. Okay? So really good use of this is with grades. So that's my example that I'm going to continue to use from this question through several more questions that we're going to work with. And probably I like this one so well because, again, it's a context that makes sense to you all for where you are, okay? So we're going to take a look at the grades. These are the grades from a first exam, right? 87, 76, 94, 58, and so on. So there's a bunch of grades for the first exam. And we're going to make a stem and leaf plot. So the first version of our stem and leaf plot will not be our final version, okay? So we're going to draw a line vertically. And I need us to find, kind of like we did on our dot plot, the lowest and the highest values. So what's the smallest value that you see in this data set? 43, actually, I think. You guys see 43? And the largest value? Yep, 94, and there's a couple of them. Okay, so the stems are going to be on the left-hand side, and what they are is they're going to be the tens digits from the grades, starting with the smallest. So 40-something is my lowest, so there's a 4, and then a 5, a 6, a 7. I've drawn them a little bit too large. An 8, and a 9. And if we have the situation where something skipped, we still represent it on the left, okay? So as we're taking a look at these, we're just going to fill them in as we go, kind of like we did with Mrs. Good's class. So we're going to go 87 and 76. So the 87, the 7 will go over here. So there's the 87. And then the 76, the 6 will go right next to the 7. Now when we have 94 and 58, same thing. So here's 94 and then 58. And then we have 82 and 43. So 82, the 2 will go right next to the 7 because that's the row that's going to have all the 80s on it. And then the 43, the 3 will go right here. 89 and 53. So 89, 53. And then 67 and 80. So 67 and 80. 90 and 94. They're going to go beside each other. 74 and 77 are as well. Now, you might notice that I'm lining mine up really nicely. It doesn't really matter because this is not my final answer, but my final answer, it is going to matter. So don't worry too much about it right now if yours are not lining up perfectly. 87 and 74. And then 89 and 90. So 89 and 90. Okay, are we good so far? All right. The reason this isn't our final version, I know we're missing a couple details, like there's no title yet, and we're going to need a key on this one. But the reason this is not our final version is because each of these lines over here on the right-hand side, the leaves parts, aren't in order. And we're going to rewrite them in order. Okay? So smallest to largest, increasing order, and so forth. So that's going to be our final version of this. So we're going to do that next. So we still have the same 4, 5, 6, 7, 8, 9. Whoops. Like that. And then we're going to put them in order. So the 43 doesn't have any order to it. There's just one number. But then when we get to the line with the 50s, 3 is before an 8. So we're going to do 3 and then 8. For the 67, the 7 would go there. And then I need to get all the 70s in order. So 4 would be first. And then there's another 4. and then there's a 6, and then there's a 7. And this is the point where we do want to make sure things are lining up. So you'll notice that the 4 right here and the 74, the second 4, should be lining up underneath the 8 and the 58. Okay, so that the lengths actually look like how many numbers are in that row. 80s, let's see, I've got a 0 and a 2, and then 2 7s and 2 9s. Does that look right to you guys? Okay, good deal. And then my 90s row, I have 2 0s and 2 4s. So this is the final version of our stem and leaf plot. It just needs a title, and we need to talk about what it looks like for it to have a key on this one. So first of all, title. What in the world is this? Yeah, and it says first exam, and the reason I specify is because I'm going to have a second exam in a moment, okay? So these are first exam grades. I think that would work. Okay. And then we need to specify what these numbers mean, right? What does a 4 on the left mean? What does a 3 on the right mean? Right? What in the world is that? So you want to make sure you choose something that's distinguishable. Like, for example, choosing 77 would not be helpful because there's a 7 on the left and a 7 on the right, and I couldn't tell you what the 7s mean because they're the same. So 43 being at the top works nicely on this one, but it doesn't have to be the first one, right? So take a number on the left with its corresponding number on the right as long as they're different. So this 4/3 is a 43 exam grade. Okay? So in looking at that now, I know that anything on the left is the tens digit, anything on the right is the ones digit, and the 43 comprises one exam. Make sense? Okay. So stem and leaf plots are just really nice for grades, and in part because grades are typically 2 digits. Now, if they weren't, if you had a grade of like 100, you would end up with a 2-digit stem on the left, right? At the bottom, you just have a 10 on the left and you have the 0 on the right, or scores that are bigger than 100. But most of the things we use stem and leaf plots for are going to have 2-digit numbers. All right, we also have what are called back-to-back stem and leaf plots. So these are 2 stem and leaf plots that are combined into a single graph, and they show a comparison of data. So in the middle will actually be the stems, and then on the right-hand and the left-hand side, the leaves will expand out. Okay? So visually, it ends up kind of looking like this, with a bunch of numbers here in the middle, and you have numbers here on the right, 0, 2, 3, 4, 7, and you've got numbers on the left, 6, 72, 73, 432, whatever. So they're sandwiched in the middle, and then there's numbers extending on either side. We're going to do an exact one, but this is the visual of what it kind of looks like. Okay, ready to look at one? All right. These are grades from a second exam. I know, second exam, and they're recorded below. It says to make a back-and-back stem and leaf plot for both sets of data. Now, before I create the back-and-back stem and leaf plot, I'm going to create the stem and leaf plot for this one. Okay? So we're going to do the exact same thing we did before and draw our stems and leaves on there. So what is our smallest value that you see in the data set?
64.
Yep, I think so. And the largest? There's even a bigger one. There's a 99 on it. Yeah. So I'd say this test probably went better, right? Those numbers are a little bit higher than the last one. So if I were just drawing the stem and leaf plot for this one, I don't have to have the 40s and the 50s on it. They'll be on the back-to-back one in a minute. But for this one, I'd really just have 6, 7, 8, and 9. So we're going to go through this. We have 93 and 96, 98 and 66, 67 and 82, 92 and 85, 64 and 81, 86 and 72, 96 and 95, 99 and 95, and then 94 and 74. By the way, this is actually real data. It's just really old data, but it's from about 12 years ago from a test that I had given, and I used it for this. Okay, so this is our stem and leaf plot. Still not quite finished. What's wrong with it? They're not in order. So as I draw my back-to-back one here in a moment, I'm actually going to draw this one more time. I'm going to sandwich these in the middle. I know my numbers has to start. It's going to have to include all of the stem and leaves from the last problem and this problem, okay? So all the stems went up to 4. So I have 4, 5, 6, 7, 8, and 9. And then because of the sort of natural feel to it, my first exam is going to go over here on the left. I'll show you how to do that in a minute. And then my second exam, the one I'm currently working with, is going to go here on the right. So we're going to use this data set and put them in order over here on the right-hand side right now. Okay? So the first line will not start at the 4 and it will not start at the 5 because I don't have any 40s or 50s within this data set, right? So we'll start with the 60s. So I have 6, 7, and 4. So I'll do 4, and then 6, and then 7. Okay, is that good for everyone? All right, and then I've got 2 and 4 for the 70s. I have 1, 2, 5, 6 for the 80s. And then I have, oh my goodness, there's a bunch of them for the 90s. Somebody help me. What's my smallest one? 2. And then 3.
5, 5. No, 4, 5, 5.
4. And then 5, 5. Feel free to mark them out. Let me make sure here. I've got 2, 3, 4, 5, 5. It's at the very beginning. Yeah. Let's see what's left. 6, 6, 8, 9. Bunch of A's. It's always nice to have bunches of A's. Okay, so the right-hand side of that, honestly, if I just took this off and I remove these first two numbers, that would look just like what we just did a minute ago, right? Not any different. Okay, I'm going to put them back in. All right, so we're going to take the stem and leaf plot we created over here, the final version of it, and I'm just going to copy paste it because I don't have it on my screen right now so that I can see it easily. And I'm going to do it in small view, but here it is right here. Okay, so here's my separate one that I've just been working with over there. See how much in there. Okay, everybody good? Okay, so we're going to start on the top row, which is 43. So normally the 4 would go in the middle and the 3 would go to the right, but we're going to extend it to the left. So we're going to go in backwards order. Now with the 4 and the 3, it sort of seems like it doesn't really matter, but with the next one it does, right? So 5, 3, 8, so 38 would normally go 3 and then 8 if I'm going to the right, but I'm moving from the inside out, so the 3 and the 8 will move from the inside out. So it'll go backwards on the left. And then we've got 67, so there's a 7 here. And then my row of 7s is going to have a 4 and a 4, and then 6 and 7. My row of 8s is 0, 2, 7, 7, 9, and 9. And then my row of 9s is 0, 0, 4, and 4. So this is my back-to-back stem and leaf plot. This is completely done, with the exception of what? Needs a title and a key. Those are the two things it still needs. Everything will always have a title. Some things will have keys. This one will. All right, so what's a title? What is this graph telling us?
Grades of the past 2.
Yeah, so these are grades for exam 1 and 2, or the first 2 exams or something like that. Key. Okay. I kind of need a row that has numbers on the left and on the right. I'm just going to choose this middle right here for no particular reason. There's a 4 on the left of the 7. There's a 2 on the right of the 7. That's kind of nice that they're different than the 7 and all of that. So that's the one I'm going to pick. So we're taking a look at those. I'm going to write my key, and it's going to look something like this. So I'm going to have the 4 on the left of 7, the 7 in the middle, and the 2 on the right of the 7, right? This is actually represented in my diagram. And we're going to say where 4/7, actually that's what I meant to do. I want to put that word above here. Where 4/7/2 means a 74 on exam 1 and a 72 on exam 2. And I'm going to move this up just a little bit so it's not running into my other pieces. Feel free to put it like in a box, almost like you would see a legend or something on a map to distinguish it. All right. Are we good? Okay, so those are stem and leaf plots. Okay, I think we can do at least one more. Our last one we're going to look at, I think, today is going to be a grouped frequency table. Grouped frequency tables groups data together in some way. Sometimes there's natural groupings. Sometimes you're told the groupings, okay? So it shows how many times data occurs in a range or class of classes or intervals. So we're going to do one that has a natural grouping because we've already got the grades data in our set right here. We've been working with it. But you could do grouped data in whatever fashion. So you could do grouped data where you're grouping whatever information by the ages of people in groups of 5, right? So you've got your 20 to 25-year-olds and your 26 to 30-year-olds, something like that. In fact, grouped data happened a lot when people were counting up COVID statistics back in the day. I don't know if you remember that or not, but they were always wanting to report it by grouped data, which was very interesting because their groups were not equal in size, which is a big no-no in statistics, by the way. Our groups need to be the same size. So as we take a look at our data has some natural types of groupings. Those natural types of groupings are known as what? How do we normally group data that's grades? Yeah, by letter, right? A's, B's, C's, and D's. This is a natural grouping for this that makes sense. Might also interest you to know that grouping that you're so familiar with 90 to 100 and 80 to 89, has not always been the grouping for graded data. So when I was in junior high, I specifically remember it changing. It changed to what you use and see now. Our data didn't look like that. 93 to 100 was always an A. And an 86 to a 92 was a B. Why did they use those numbers? I'm not sure why those numbers specifically were chosen, but it was changed. So what's natural for us to group certain data in is not necessarily the way it's always naturally been, right? A little bit of that is cultural, right? How do we culturally do that? Well, with grades, for the most part, we culturally do that in groups of 10. So as we're taking a look at this, that's how we're going to group this data. So we're going to create a chart. We're going to have our grade over here. And our lowest grade here is actually in the 60s. So while we could do grades lower, it's not necessary. And our highest grades are in the 90s. So we're going to do our grades that go from 60 to 69, 70 to 79, 80 to 89. And we're going to do 90 to 99, number one, because there aren't any hundreds here. And number two, because I am trying to model it to represent that all of the data sets are equally distributed. And if I make it 100, it's actually kind of fudging it a little bit. It's not quite evenly distributed. So we're going to go with it being perfectly aligned there. And then what goes in the middle is a tally. We're going to make a tally chart in the middle. Okay. So we're just going to go through and we're going to lose specificity of all of our grades by putting them into categories, which is exactly what happens when your grades go onto your transcript, right? If you got a 99 and somebody else got a 91, do you know what your transcript says? A. It doesn't matter, right? You get a little bit more specificity if there's pluses and minuses, which we don't have and some schools do, but you still lose some of it, right? Either way. So 60 to 69, 70 to 79, 80 to 89, and 90 to 99. So I'm just going to go down like I did before. This is 90 and 90, so I've got 2 marks here. I've got a 90 and a 60, 60 and 80, 90 and 85, 92, 85, 64, 81, 86, 72, 96, 95. We can mark it as a 5th mark over. Okay, so 90 and 90, or 95, 96. Was that? Yeah, and then I have 99 and 95, and then 94 and 74. So they're a little bit sloppy, but they're not too bad. Okay, so the tally column, we have that there. And then our last column is called a frequency column. Frequency is just the numerical digit associated with the tally mark. So for example, on the 60s, there's 3 tally marks, so we're going to write a 3. It's not a very exciting column. And then we have 2 70s, we have 4 80s, and we have 9 90s. Okay, so we're just numerically representing it. And then it still needs a title. So as we take a look at a title on this one, what do you think a title might be for this? It's not a standard grading scale. That's what the data looks like overall. But what's the data it's representing? The letter grades or the grades on a test. So you're welcome to write letter grades if you want. We did never put the A's and B's and C's in, so I'm not going to write it that way. But this is grades on, and if you look back up, it actually tells you again it's on a second exam. Okay. I actually think we have time for histograms, so we're gonna do that. Okay, are we good with this? Okay, let's look at histogram. It's a pretty quick one. A histogram is made up of adjoining rectangles or bars. The categories are shown along the horizontal axis, and the frequency is along the vertical axis. So if you've already created a group frequency set, which we did for the data, it's actually just a visual, it's a picture of what that data represented. All right? So I'm going to copy my data set from over here, my group frequency table, so that we have it represented. Notice this is the same data. Again, we're just doing it in a different way. So our data right here, I'm going to put it up here at the top, looks like that. Okay, so a histogram is going to be like, I'm going to use the word bar chart. It's not a bar chart. It has bars because we're going to actually do a bar graph later on. Okay, so it's slightly different, but it looks similar. So on the bottom are the data values that we had. And so that went from 60, and then we had 70, and then 80, and then 90, and then 100, like that. 60, 70, 80, 90, 100. So these down here are our grades. So we need to anytime we have this kind of a graph, we're going to label the axis. What does the axis represent? And then the vertical axis over here represents the frequency. So what's the biggest frequency in our chart? 9. So it's going to have to go up to 9. So once again, if it was a lot of values, you're welcome to put them in groups of 5 or label every other one or whatever. This one's small. We're labeling everything because there's no need not to. So we have our 1, 2, 3, 4, 5, 6, 7, 8, and 9. Again, everything should be roughly equal, right? The spaces should be about the same. It should look convincingly the same. All right, and then what we're going to do is we're going to take a look at the frequency values. So in the 60s column, it says 3, right? So we're going to create a bar, the width from 60 to 70, and the height of 3. And then we're going to do the same thing for the 70s. There's only 2 on this one. So from 70 to 80, height of 2. From 80 to 90, height of 4. And these should look like they're actually touching sides. I'm trying to make mine work right. And then we have 90 to 99 or 90 to 100, which would be our last value, which is 9. So this one's supposed to go up all the way to 9. There's 2 things currently missing on my picture. What are they? Title's one of them, so let's do that. What's the title for this?
Could you do grades on a second?
Yeah, it's going to start to sound boring because we're using the same data set every time, yes. These are grades on a second exam. Any idea what else is missing?
Label on your vertical axis.
Yeah, I need labels on both axes. I said it, but then we never did it. We have the label on the bottom one says grades. The label on the vertical one, or the one that's going up, kind of like our y-axis, is frequency. And we need to write that in. Okay, we will pick up with example 7 next time.